Hello everyone, welcome back to Management Information Systems. Today we're going to be talking about enhancing decision making. So what do we mean by enhancing decision making? We understand that through businesses, we have to take many managerial decisions. However, in the past, many of these managerial decisions, they have been always based on data, but previously it was more subject to the human mistakes in some certain way. There was presented information, but there were many areas or correlations or connections that were not being able to seen by the human. And that's something that information systems are doing nowadays, which is they are able to see more broadly the data, more broadly as in a wider spectrum, but also in a narrower and a more finite way, meaning that also we can see larger amounts of information and we can get specific things that we want, right? As compared to previously, that was more generic. So that is something that we're going to talk about today. A big data and the Internet of Things drive precision in agriculture. Here, for example, there's one example. That we have many. Well, let's rephrase that. Initially, we have the farming in general uses a lot of obsolete technology. So with that means that production sometimes is not efficient. That there's many leftovers, spoilages, wastages, etc. So the problem is that now the demand is growing. I mean, as the population of the world grows, the demand is growing, and we need to have better systems in order to do that. So this is, for example, when information systems, the big data and Internet of Things come in, as in implementing sensors, putting in the machines. Well, this is hard to really explain. As in, for example, all the farming technology has been more developed. One of the examples of them is Deere. Deere company is something that they understood that by having all those farming farming cars, tractors, etc., diggers, they were inefficient because they were somehow sometimes damaging the floor or sometimes damaging the vegetables or the ingredients. So one of the strategic areas of Deere and company was to innovate through all the sensors, all the machines, and they did it very well. We saw that Deere started to grow exponentially from 2 years before, right? Because they were starting to offer better solutions to the farmers. They were starting to get more productive, and because of these technologies, they outspaced other companies, like for example, like Caterpillar, which also has some of the same machinery, but they haven't coped with those changes the same way that Deere has done it. That is in terms of the hardware for harvesting, but also we have in terms of the software. In terms of the software is the analytics of the demand. This one has, we see an increased pressure from supermarkets, from retailers in general, that they want larger quantities. So for them to measure the demand and try to cope with it, this has been also one area that has improved through information systems, right? So now, when we have when we talk about um, decisions, let's say for example in the previous example is more in the farming, as in we have top management, which is the retailers, saying we need to cover the demand in better ways. So if we put it in that way, this is just a big statement. We need to improve the production because we're not coping with the demand. Then it goes to the middle management. Then they design an operation in which, okay, who do we need to talk already um, to increase that? So in this area comes, for example, distributors. The distributors are where they say, okay, guys, we need to ramp up the production. How do we can do it? it starts to already being more concise, because like I said, it comes from a general statement that says let's improve production, then talk to producers, and then goes already to the structure, which is to the actual farmers. So in the actual farmers, that is where really we're gonna see the implementation of the systems and the programs and the software and the hardware, etc., in order to really step up the production. So it goes from very rough idea to hands-on to the lower management. So that's why we're saying that we need well, when we are doing key decision making, it varies according to the groups depending on what they want and their agenda. So when we're going through this decision making process, first of all, we need the intelligence. So what is intelligence? Pretty much is understanding uh, what kind of uh, what kind of problems we have, what kind of data we have. Well, the problems come after collecting the data. We have a lot of data and we have to try to make some intelligence out of it. Meaning that we have a lot of unstructured data. It could be, for example, from the farming, and we need to understand the patterns. We understand that maybe, for example, when there's the seasonal changes, there's some patterns changing, and we can only know that through data. Maybe farmers manually were not able to see it. Maybe roughly understand it, but not in a very precise way. So if we see this problem, like I said, the data that gives us some intelligence, and then is where we start to generate knowledge, which is we need to design what problems, what solutions we can offer based on that data. Some of them, it could be tangible in terms of actions, it could be strategies, it could be in terms of pumping some money or some resources into that. And then we have the choices where we go into this decision making process. When we have all these a kind of softwares, these information systems, we get a lot of options where we can do an analysis of the risk and the costs and which one will be a better option. Usually these kind of softwares, what they develop is a decision tree. If I were to do this option, the success rate is 80%, the failure rate is 20%, but the profit is maybe 20 million and the downside is maybe 5 million. So it sounds good. Maybe it gives me option B. In option B, maybe we can just implement this software. Then on the upside, maybe we just make 20 million. The downside, we don't lose anything. So also it's a good option. So in this case, we do the calculations, and then through the information, we can forecast what could be the best option, and we have an informed decision. Because this is what used to happen before, that we didn't have that much information and we did unstructured decisions. There was no rationale for that. Okay, so anyways, there comes implementation. We understand what was the best option on paper, and then on action is where we put it in, and then we see how it works. Okay, so anyways, we have the managerial roles in information system. We have they are always, all this information is usually provided by some departments, and then comes the managers that take strategic decisions. In this case, we have the classical model of management or more contemporary behavioral models, which is classical model goes into planning, organizing, coordinating, deciding, and controlling, which is classical, but still is very well practiced in the industry. Though we have the more contemporary behavioral models, which is not to say that it's not structured, because it's still structured and it's still based on data. The problem is that now data flows more, flows faster than before, and taking actions doesn't go through all the process. We really just take the action based on the data, and that's it. So that's what we call a more contemporary behavioral model. And it's just because, like I said, we have much more information and we need to take decisions faster, because we cannot, previous time in more analog models, we could wait maybe 2 quarters, 1 year to take decisions, and nowadays it's matter of months. In this case, we have the example of the fast fashion behaves a lot on these information systems with a more contemporary behavioral model. As we see the demand changes, the supply has to change. If the people like one color, they produce more. If they don't like one color, they don't produce anymore, and then that produces a better revenue for the company. Okay, very good. So we have three main reasons why investments in IT do not always produce positive results. So far, I have explained to you that information systems are very useful. They generate data, blah, 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 blah. And in theory, it sounds fantastic. The problem is sometimes in the real life, they say it's like finding, big data and data analysis sometimes is also like the needle in the haystack. We don't know what you're looking for. We have a lot of information. We don't know where to start. And in the end, it's not, or we grab pieces of information that are not useful. So first of all, we need the data quality, information quality. Where do we get that information from? How we get it, how it's structured, how it connects. And that is one of the first things. If the data doesn't have a good structure, we're already doomed. It's already going to generate false information. Then we have the management filters, which is managers have their own biases for many reasons. Maybe because of their previous managerial experience, because of previous cases, because of the way they behave with the data, etc. So management not always takes the best decisions. Sometimes they are biased because of their own agendas. We could have a manager that perhaps has a more marketing approach, a financial approach, and he may go into that decision ignoring that the financial area perhaps is the most important in a certain project. So that could be. And then finally, we have organizational inertia and politics. When we implement systems, when we do changes, there's going to be a resistance to change. We already have, precisely here, we have the word inertia. So we have to imagine that is like a big truck. A company is like a massive truck or a massive train. That's even a better example. We have a massive train. So we're just going to stop it and we're going to change the direction. Then that's not possible. You understand that even if you want to brake here, you still have to go through some meters in order to change. So that is what happens already with changes in information. We see that information is telling us that we need to do some changes. Like I was telling you, we need to be more prompt with the changes because we have information upcoming. So what do? We wait for the quarter or the semester or the year to change. Not all the time is possible. Sometimes when we're talking about smaller companies, it's possible. Get rid of the project, scrap it and buy, but not with a big company. Sometimes big companies, they say, okay, we have contract agreements with different companies and we have to fulfill them at least for the next year. Yes, we know that for next year we're not going to continue doing what we're doing, but so far we need to scrap the material. We cannot scrap the material. We have to continue doing what we're doing, but we know it's not well done. So sometimes, again, regardless, we have a lot of information, good information to make managerial changes. We still have to go through them because the company cannot just quickly change. And that is one of the benefits of smaller companies, that they can react very quickly to market changes as compared to larger companies. And here I have, again, high velocity automated decision making. Precisely what I was mentioning to you right now is that because we have a lot of data coming in, we can take decisions if the company is able to change them. But if not, then we have to just stay on course and continue with what we're doing. So anyways, here what I was saying is, what is business intelligence? I already mentioned it, but just to go a little bit deeper into that, business intelligence is somehow the infrastructure for collecting, storing, analyzing the data produced by the business. So where does this data comes from? From everywhere. Let's put the example that I want to go through the production of I don't know, something very simple, something that maybe cars, right? So we have information from the consumers, what they want. We have information from the distributors, what they sell. We have the information from logistics, where they move. We'll have information from the production, how they produce, how often, how much, when they stop. And we have data from the financials. So how does it all come together? So it comes all together to, for example, systems like ERP systems, which we already spoke about that in previous units, which is connecting the data from all the different departments, right? So now we have tons of data. Most importantly is that we have synergy within data, because if there are data silos, that means that information is parked into individual departments and there's no connection. That doesn't happen with, for example, with a manufacturing car company. So in this case, we need to look at all the data, have it all together, compile into one single place, or accessible. It could be in different places, but accessible to everyone. And then we carry on and doing the business analytics, which is we're going to use statistics models, data mining, all these big data, artificial intelligence, because all of these systems are able to see all the connections within the data. Sometimes as humans, we are humans, we can see the obvious, but precisely these systems, what they are able to do is to find relationships in things that are not that obvious. And this has generated a lot of insights for many, many, many businesses. I remember there was one case of Target, the supermarket, which they were figuring out, based on the data that they have, the purchasing behavior of some teen pregnant ladies. So based on that, they didn't notice it. They was just noticing that there were some changes into the behavior of the purchasing pattern, but it became obvious only after the computer was able to say, there's a pattern here and you should observe it. So again, in this case, it generates a lot of insights, but of course, we need to understand that we need to implement a system before doing all this analysis, this intelligence. So we need to think of the infrastructure of who is gonna sell us that system. In this case, for example, here we have business intelligence vendors like SAP, like Oracle, Microsoft. They have a lot of these softwares for data analyzing and intelligence. But I mean, everything will vary according to the purchasing power of the company. Some softwares are very powerful and they are able to generate a lot of intelligence, but they come with a tag price. So in the end, we have to do an assessment whether that system pays off according to our operation. That is the first thing. And the second thing is that nowadays, many companies still think that it's not necessary because they see it as a cost. They see, if I put a data analytics system, I have to pay this much money, but they don't see the benefit that can bring to them. So we need to see IT as a permanent cost, and that works very well. It's like, for example, I can say, I'm a restaurant, and I'm not going to turn off the lights. They're not going to turn on the lights because then I could spend a lot of money. And it's the same thing with data analytics. I'm not going to I'm not going to get any data analytics because it's expensive. Yeah, but if you don't have light, then you don't have customers. The same thing, if you don't have a data analysis, you don't know what you're doing right or what you're doing wrong. So in the end, it is necessary. Okay, very good. So anyways, let's talk about the business intelligence environment, which we have data from the business environment, like I said, different areas. Then we have intelligence infrastructure, how we extract that data, where we park that data. We go to the analytics, through which software we analyze them. And then the delivery platform, which is how we put it in a software that has any graphical information. I have already mentioned that in the previous unit, where we can have a dashboard. Okay, so I could see tons of data, and I think I have it somewhere. Here, for example, I'll give you an example. We have a lot of data in Excel, and then we can use a pivot table. Tons of data here. Doesn't make sense? So we have some visualization in here, a table that tells us by regions, email, web, grand total. So already, to me, it's much faster to see, which one is the largest one? Very quick, I can say West is the largest one. Just I'm saying an example. Okay, so that works very, very, very well. And that's precisely the beauty of dashboards. That one is not a dashboard, but there's some companies that really have some softwares that present the dashboard very, very nicely. As in, it could be by region. It appears a map, and then in this one, like the southern part was the most profitable, maybe generate the most, then it already appears in blue, and then the west in red, and then according to. So that's precisely the use of dashboards, because we understand that not everybody knows how to read data, but with the dashboards we make it easy, and then of course we can generate some queries. So this is where we go here. When we go to the capabilities of this software. So when we get these softwares, we can produce reports of the things that we want. For example, it could be in terms of the production. Parameterized reports. We put some parameters. I need you to present the relationship on. It's not just a big amount of data. I just want you to present specifically the relation between this one and this one. Okay. Then we have the dashboard and the scorecards, which is graphically present the result instead of presenting a lot of data. This is very useful when taking the managerial decisions. You go to a presentation, and the presentation, boom, this is the table, this is the graph, this is where we are and where we want to go to. Okay, so in this case, like I said, also these softwares, they allow us to do ad hoc query, which is we can just look up for specific information within that software without going through all the data. It's just by typing, okay, West region, like I was saying in the example before, West region, click, click, click. Okay, West region appears already the detail. So, and then create a report based on that, right? So the same thing as the drill down, forecast scenarios and models. We will look back into the information that previously have, if there's any patterns in the previous information, and then also we go to the future, as in forecasting. If I change this in the production, how would that affect the demand? So based on this, many companies take a lot of decisions of maybe producing more or producing less. In this case, for example, they forecast that Christmas is coming, and they took the analytics of all the data across their market. They analyze the data. They understand that now there are shortages in the supply. So, for example, precisely in this year, something happened fantastically, which was done with business intelligence. Most of the large retailers, such as Walmart, Target, they knew there's a shortage of supplies. So for Christmas, and what they said, okay, let's start to sell Christmas sales in advance and also Black Friday sales in advance. So they started some weeks earlier in order to avoid the shortage in production. Okay, so that is all done through these softwares. Nobody comes and say like, I think no. Nobody comes up with their own ideas. So in this case, like I said, we have different examples. I was telling you in production, it can be in sales. We can forecast the sales. If we are doing the same thing that we're doing right now, what do we see in the future? Service calls, service center, how many calls we got a day, how many we dropped in, what was the duration of the call, the satisfaction, etc., marketing, etc. This one you can all read on your own. But again, there's many applications. Data analysis pretty much works for everything. You can get data analytics out of everything. You can analyze anything that you want, and you will be able to see patterns, connections, etc. Okay. So Now, well, I already mentioned this, the predictive analytics and forecasting. This one we use a lot of statistical analysis, a lot of algorithms, and the data mining, assumptions, reading, understanding. The data goes through a process of see where it is and the potential to understand where it goes to. So here, for example, there was for banking the credit scoring. We analyze information of the customer as in okay, he has this salary, he works in this industry, he has spent so much money every month, he has a debt in this, tuck, 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 he has a car, tuck, 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 tuck. The computer does the calculation and say, well, this guy's good in credit because he, according to these patterns, then he has a good credit score, and then maybe we can lend him his salary 5 times for saying something, or lend him the money for the house, right? So that works. That works very well. But anyways, this is just an example. There's many examples of predictive analytics, and predictive analytics are just mostly based on the data that we have, and we can jump already into big data analytics. Big data analytics is already goes into external information. We analyze social media. We can realize we can do from Internet of Things, from any data from many places. I assume that you already know why it's called big data, but in case you don't remember, just big data is very simple. Is imagine that when I turn on my computer, I generated data. The moment I pass my cursor of the mouse here, where it was generates data, how long I stayed on the website, what did I purchase, did I purchase it or not, did I put it in my basket, did I pay with credit card, did I pay it by transfer. All of that generates a lot of information. Where did I buy it, what time of the day, was it a computer, was it a tablet? Imagine, just I mentioned now just randomly like 10 things. Now multiply that times times the time you spend on a computer. That's already a lot of data. Multiply it times, let's say, 1 billion Chinese. Multiply it times the world. That is big data, okay, in a nutshell. So that's why we require a very powerful data analyzer in big data that can come and tell us the patterns into that data. Okay, very good. So that leads us to operational intelligence, which is now we have data, we analyze it, and we put it into action. Okay, very good. So now we have also location analytics and geographic information systems. Through the GPS, we also get a lot of data. That goes again together with all the big data. Okay, like I said, the big data, we can get it from the operations, from what we do every day. We can do it from the location. I already mentioned, like I said, I just mentioned it just very roughly. Okay, so we can get data from many places, and we can use it in many ways. I already explained that. Okay, so now we already explored through this unit where we collect that data, and then what we need to think is, what is this for? So to make decisions, and I already mentioned that too. We do it to make decisions, but with evidence. And let's take this as a criminal case. In a criminal case, you say he is guilty. Why is he guilty? You need to present all the evidence. Same happens in business. I'm gonna implement this marketing strategy, or I'm gonna increase the production of the product. Why? Because I feel that in the future there will be people needing more of my shoes. No. You have to say, we have this information based on the analysis. Like I said, for example, here I have on the West region 211. So we're going to focus first on the west, or first we're going to focus on the north because it has the least. So again, it goes together with the information, the managerial decisions. It can be either bias. I can focus on, say, if it's not broken, don't try to fix it. So if west area is not broken, why I try to sell them more? Maybe I'll try to fix the north, which has the sell. No, this is just like very random example, but that is how it works, right? So all these softwares will tell us, okay, if you focus on the west area, this is what it will happen. The software gives us that. And this gives us a level of confidence, meaning that when we take a managerial decision, we have, let's say, level of confidence of 95%, 95% of confidence that this will happen the way that I wanted or that I predicted it. And if that fails, then we understand that there's a chance of failing because, well, maybe I produced more and I forecasted that people were going to buy this, and maybe I made more Jordan shoes, but suddenly LeBron James becomes more famous and nobody buys me those Jordan shoes, right? So there's things that, of course, like I said, within that level of confidence, I said 95, then that 5% can happen things that are not calculated. So if I were to screw up in that way, at least I could say, well, I took the decisions based on the data and not based on my feelings. And that is precisely why we use all these decision support systems, because it's like I use it as to support what I'm trying to sell or to do or so. Okay. So anyways, all of this decision support for senior management is presented in the sense of many ways. No, it could be in terms of the money, as in how we're going to use the money. This is this balance scorecard is a very popular approach. So which is, like I said, we can generate data to support how much money I'm spending, or which processes I'm changing, or which R&D I'm doing, or how am I treating my customers. So it could be into many areas, and it's just, like I said, supporting your decision that you're taking. If I have a strategy and I'm going to change something, I will support it with data. Okay, very good. So I mean, in the end, that is pretty much what we have in there. This one, it talks about group decision support system. Group decision support system is just the same thing. It is just that, like I was explaining before, when the data is open and accessible to everyone, maybe the decisions are no longer taken just by one department. They will be taken by different departments because they all have access to the data, and they may see the data in a different light according to their needs, according to the thing. So in this case, now we have softwares that allow us to do that. Here, for example, there's many collaboration tools. Here they put Skype for Business. That's the slide, but I mean, this is the original slide. It's collaboration verbally, but usually when we're talking about information systems, we're talking about collaboration in terms of everyone having access to the data. Okay, very good. So that's it for now. So in the end, to conclude this unit, is information systems in general are useful for taking decisions, ground decisions. We do this because we have the data to support it, and then we expect to happen this, and we will minimize the risk because we already calculated or forecasted what could possibly happen. So pretty much that's all. If you have any questions, please let me know, and thank you so much.